Today we are going to see V and inverted V curves of three-phase synchronous motor. This is a circuit diagram. It's a armature side connected synchronous motor. We are going to give the AC power supply to the armature winding with the help of three-phase auto transformer, and seriously we are connecting the ammeter for current measurement, and parallelly we are connecting the voltmeter for voltage measurement. Then for power measurement we are connecting the wattmeter. After that, in field side we are going to give the DC power supply to the field winding with the help of variable rheostat. The current can be measured by the ammeter. Then for loading arrangement we are going to use the brake drum. Let me see the experimental setup for the V and inverter V curves of three-phase synchronous motor. This is the experimental setup of V and inverter V curves. Now we are going to give the AC power supply. These are AC power supply input to the auto transformer input. The auto transformer output is connected with the voltmeter, wattmeter, then ammeter. For voltage measurement we are going to use the voltmeter. For current measurement we are connecting the ammeter in series connection. Then power measurement we are going to use the wattmeter. This is the stator side or armature side connection. For DC power supply we are going to provide the DC source. This is a positive and negative DC supply that is connected with 2 amps 220 ohm rheostat, variable rheostat, and this current is measured by the ammeter and is given to the field winding. So now we are going to switch on the power supply. When we switch on the MCB, so the three lines are indicated. Now we are going to start when you are starting with the current is gradually increased. Automatically we can get the here rated voltage we have to give. The input voltage become 400 voltage. So let us set as 100 into 400 voltage we are going to give it as an input. After that we are going to switch on the DC power supply. Now the switch DC power supply is given. We can get the DC the input current in the ammeter, then rated current in the armature side, and voltage you can measure. The wattmeter indicates the reading. Actually we are going to tabulate the value, tabulation, field current, line current, input power and power factor. For power factor we are going to use the formula. We are going to note only three values alone. Field current mentioned in this one. Field current, this is the line current, this is the input power. The voltages we are setting at initially 400 voltage. So by varying this field rheostat, we can increase the field current. The corresponding current can be reduced, then power as well as the voltage. Voltage remains constant 1. Then again we are going to increase the field current, the corresponding current, then take the 5 readings for up to rated field current. After that here the loading arrangement should be in without load condition. That means the load is not connected, the motor is running at constant speed, the load remains 0. After that we have to apply the load by varying this loading arrangement. Now we are getting the loading arrangement. So we loaded the motor. Then similarly we are going to adjust the field current and take the reading of field current ammeter, then wattmeter reading, then voltmeter for 5 readings, and draw the graph between the DC excitation current power factor as well as the field excitation current versus corresponding armature current. So this curve will flow the V and inverter V curves of the field current versus armature current V curve, then field current versus power factor, that's the inverter V curve. We have to draw the curve accordingly. So we have to set it into the initial position. After that we have to switch off the DC power supply, then we have to reduce it gradually to stop the motor.